Naming compounds and writing out formulas is something that students find very difficult. One of the things that can make that easier if you're very familiar with the names and symbols for some common ions. Does anybody know what the name for the ion is below? The NO3 minus ion? The name for that one is nitrate. So nitrate is just one of many ions. Let's take a look at a large list of common ions. So here's a list of 52 common ions. And what's going to make things easier for you to work with naming compounds and writing formulas is to commit this list to memory. Really? Commit that to memory? That's 52 ions. How is that even possible? Well, I'm going to show you some techniques and some tips that'll make that a lot easier. Now, many of the examples have Roman numerals next to them. These are going to be some easy ones. Like up here we have chromium 2 and chromium 3. All you have to do is just remember that the Roman numeral indicates a charge in the metal. So therefore, if we take a look at chromium 2, what you can see here is that the charge noted by the Roman numeral is 2, and then the charge on the ion is 2. This one says chromium 3, so the charge on chromium is 3+. Look at one over here, we have lead 2, that means that the charge on lead is 2+. Lead is 4, so that means that the charge is lead 4+. So what that means is that we really don't have to study those. Once we realize that the Roman numerals are equal to the charge in the metal, we can just eliminate these from the ones that we would have to study. So that certainly narrows it down a little bit, but there's still a lot of ions left on there. Let me show you another tip that'll help to make things even easier. So there's a lot of elements that we can predict what the charge is based upon its location on the periodic table. And so here's a quick look at a rough outline of the periodic table. Let's start looking at a couple examples like this. So we have aluminum that has a charge of 3+, and that's because it's in the 3+ column. We have an element like bromide. That one is going to be down around here. It's in the -1 column. Oxide is -2. It's up here in the -2 column. And so based upon where the element's located, we can figure out what kind of charge it's going to have. So on the right hand side of the periodic table, we're going to have our nonmetals, and they're going to gain electrons. So group number 7 is going to gain 1 electron to become a -1 ion. Group 6 will be gaining 2 electrons to have a -2 ion, so on and so forth. From the metal side, group 1 will lose 1 electron to form a +1 ion. Group 2 will lose 2 electrons to form a +2 ion. And so there's a lot of elements that we can just predict what the charge is going to be based upon its location on the periodic table. So if you don't have these charges labeled on your own periodic table, you might want to go ahead and do that now to make your job a little bit easier. And so with this knowledge, we can cross off several more elements from the periodic table that we're not going to have to study. So we seem to have the list down to about a half. Let me show you one more tip. Most of the ions that are left are polyatomic ions, that is, ions that contain multiple atoms. And there's a very set pattern for how they go about naming these ions. The ones that contain oxygen, such as this one up here, bromate, or this one here, carbonate, they like to have an ATE ending when they contain that oxygen. So what would you do, though, if you had an example like nitrate and nitrite, where these two ions both have the oxygens, but they have a different number of oxygens? What they decided to do is they decided to come up with a system where the one that has fewer oxygens gets an ITE ending. So what you can say there is that the one that has the ite is light on oxygen. And so if you were to memorize NO3 has a charge of -1 and is called nitrate, all you'd have to do to figure out what the nitrite is just subtract one of the oxygens. So you go from NO3 to NO2. Now, the series that I have over here on the right-hand side, this shows as bad as it possibly can get. And because if you take a look at the chlorine and oxygen series, there's one that has 1 oxygen, one with 2, all the way up to 4 oxygens. So they had to come up with a way to have distinguishing names for all 4 of these different ions. So you can see here that the third one down of the ones with oxygen in it gets the ATE ending. We're going to call that the normal number of oxygens. And ite is going to have one less oxygen. They're going to use the prefix hypo to mean less, and then the suffix ite also means less. So that winds up being two less oxygens than the one with chlorate. And per is going to be a prefix meaning more, and so it's going to have one more than the normal amount of oxygen that you see for the chlorate. So what I would suggest then as you're going through and working on these and trying to memorize them is really only focus on the ones that have 8 that don't have the prefix per there. And so it's going to cross off a whole bunch more on our list we really don't have to study. Let's take a look at what we have left. So for the ions that are left, what you want to do is you want to try to group them together a little bit, try to figure out which ones have a -1 charge, maybe which ones have 3 oxygens. There's a few like the ones over on the bottom left here that are really just a combination of hydrogen with one of the other polyatomic ions that you should already know, so maybe we can go ahead and cross those 3 off, the dihydrogen phosphate, the hydrogen carbonate, and the hydrogen sulfate. And so it's probably not too bad to learn all these ions. Good luck.